All right, in this lesson, we will be introducing domain and range. This is a topic that we will be spending two class periods working on. But what I want you to do for next time is to go through this lesson video, take down the notes, and then I also want you to read the textbook. You guys are pretty much aware that my notes follow each textbook lesson, but I do think it's helpful for you to read your textbook as well, okay? So we will be working on this material next time. All right, so let's talk first about what domain and range of a function is. We do need to know that a function is only defined for certain values of the independent variable. Remember, our independent variable is our input. Thus, the dependent variable only takes on certain values depending on what the input is. If a function is used to represent a real-world situation, the constraints of the situation will determine the value that your input and thus your output will have. So when we talk about domain is the set of all allowable input values of a function. And again, what is allowed in a function is determined by what situation the function is representing. So it's going to be different for everyone. The range then is the set of corresponding output values. Of that function. Okay, so domain associate with the allowable input values. The range is then the corresponding output values. All right, let's look at our first example to just kind of introduce us into how domain and range is determined by the situation given. It says the charge for a taxi ride is $3.50 for the first eighth of a mile and 25 cents for each additional eighth of a mile, and you always round up to the nearest eighth of a mile. So we are going to give a domain and range that would make sense for this problem. So we have to kind of think about what our input is. Our input here would be our ride length, how far we've gone in the taxi, okay? It's important to identify the input because that's what then determines your domain. So if our input is the length of the taxi ride, then think about what the corresponding domain would be. If the length of the ride is the input, then the domain, which we use an x for, that's our typical input, has to be greater than or equal to 0, okay? You could get in that taxi and decide, oh wait, I don't need a taxi, I can walk to where I'm going, so you get out, the length of your ride is nothing, and then it could be anywhere beyond that, okay? We should say that, though, your ride will end at some point. I hope no one's just taking a never-ending taxi ride in their life. So we do want to include the end of the ride. So to do that, we're just going to kind of make this generic. We're going to say the length of the ride, which is x, has to be greater than or equal to 0. That's what we had first. But then it has to be less than or equal to e for end of the ride, okay? So we don't really know what the exact end is, but we're just going to make it generic, saying at some point your ride is going to end, okay? Hang on a second. So once we have our domain, then we can look at the corresponding range. So range is going to be, again, corresponding output values for your domain. So let's think about this. Let's think about one end of it. If your ride length is $0, then your price will also be 0. So the price has to be greater than or equal to 0, but then it has to be less than or equal to f of e. And hopefully we understand at this point what that means, just the output when your input is e. So no matter what that end amount is, you would take the output value. Okay. One of the main ways that we are going to find domain and range is using a graph and using our graphing calculators. Okay. So if you don't have it out, go ahead and grab it and have it handy. As it says, when estimating a domain and range from the graph of a function, remember that the domain is the set of input values on the horizontal axis, and the range is the set of output values on the vertical axis, okay? So, with that in mind, a sunflower plant is measured every day t from day 0 on. The height, h of t, is in centimeters. That's the height of your plant. The height is measured using that function. So the first thing that we are going to do is we are going to use our graphing calculators and graph the height over 80 days. So grab your calculators, and we are going to put this function into our y1. I'm going to put that 260 in parentheses in my numerator. I'm going to divide that by the denominator. Now really pay attention to how I'm entering this in my calculator. You have to be, especially with the older TI-83s, you have to be very specific about the use of parentheses to make sure that you're really entering in the function you intend. So take a look at how I'm entering this. And I know it's t, a function of t, but we only have the x, so it's going to be the same thing. Okay, so again, just take a look at how I entered that in. And then we want to graph the height over 80 days. So I'm going to go to my window, and I apologize, I apparently have a line out on my calculator. But we're going to graph this over 80 days. So I'm going to want my horizontal axis to go from 0 to, how about 90, just so we can see our input a little bit beyond what we want, okay? And then let's go ahead and graph that, and then we can see our graph here. So part B then is asking us, what is the domain of this function? Okay, so the domain is our input. So we know we're starting with when t is 0. So I'm going to use the variable t as my variable since that is what they're defining as the input. I know that t has to be greater than or equal to 0, but very similar to the cab ride, unfortunately, the flower will someday die. So if we consider that, t has to be greater than or equal to 0, but then less than or equal to, this is really morbid, but capital D for when the flower dies. Sad. Okay. And then the next question, what is the range of this function? Okay, so what we're going to do is actually go to our table. So second graph for your table. Ooh, I need to change my table set. Your table is probably like mine now, okay? So I'm looking at, again, the lowest value of my domain, which is 0, and you can see the output there. What that means is when we first had the sunflower planted, it was already 10.4 centimeters. Now we want to look at the highest of our interval. And for this, we don't know when it's going to die, but it tells us to graph it over 80 days. So the upper interval of my range will be the output for 80 days. So instead of scrolling all the way down, what you guys can do is hit second window, which is table set, and you can tell your table where to start, okay? So I'm concerned about what happens when x is 80, so type that in and then go back to your table and it will jump right there, okay? Now, if you look beyond, notice what's happening. The flower's getting a little bit bigger, but barely. We're gonna go ahead and just round that up to 260, okay? Just for a little rounding sake. All right, so then part D, what does this tell you about the height of the sunflower? The average height of an adult sunflower is about the 260 centimeters. We saw once we got to about 80 days, it really leveled off at about 260, okay? All right, last few examples here. So like I said, a lot of times what I'll tell you for domain and range is to look at the graph. That's always a good thing to do, but we can also algebraically look at finding domain and range, okay? So in order to find the domain and range, we must consider the values that make the function undefined. So a couple of algebraic, I don't want to say tricks, but things to remember. We cannot have a 0 in the denominator, and we cannot have a negative under a square root. So those are a couple of things I said algebraically to keep in mind as you're finding domain and range. So for example, oh, and I'm sorry, this should not be there. Hopefully that's not in your paper. We want to find the domain and range for f of x equals 1 over x. So here's what I suggest. Number 1, go and graph it. So y equals 1 over x. And what I'm looking for, I'm looking along my horizontal axis at x values. And what I'm seeing is there's nothing at 0. That can also be verified by looking at the table. Look at what happens when x is 0. It tells you error. And that's for this reason, because if you put 0 in the denominator, it's undefined. So what we'll say is the domain is all real numbers. That symbol means all real numbers except 0. Okay. Well, if the domain cannot have an input of 0, the corresponding range is going to be the same, all real numbers except 0. Okay. And again, if you look back at the graph, you'll kind of see that. If you look at your y values, you're on top of the on top of the x-axis here, getting positive y values. You're below the x-axis here, getting negative y values, but you don't have 0. If you look at the second one, this goes along with our second algebraic thing to remember. You can't have a negative under your square root. Okay? So again, first thing, go to your graph. 1 divided by square root of x minus 2 and graph it. Look at the graph. Look what happens. I'm only seeing a graph at x values that start here. I always go back and look at the table to see table values. And if you notice, you're seeing the same thing. I see error, 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 error until I get to 3. And that's because what's under the denominator has to be greater than 0. So if I solve that, my x values must be greater than 2. Okay? So that is our domain. Our range if you look at the y values, they start up here and they decrease, decrease, decrease. They approach that horizontal axis but never reach it. Again, you can look at your table for that. Look at those y values. They're getting smaller, but they're never going to actually approach 0. So what we say is that the range, you can use f of x or you can use y. Those values have to be greater than 0. And then last one. Type it in. 2x minus 3, graph it. It's just a straight line. Hopefully we recognize that as a linear function. Okay? A linear function does not have any restricted domain or range values. So for both of these, our domain and our range is going to be all real numbers.